Now you can see, by the way, these questions differentiate blah and hence do something else. They tend to be the kinds of questions where they don't match what you're being asked to get. Doesn't match a nice memorized form that you already have, something we don't have a shortcut for. Okay, and sure enough, log x on x squared. Like, what do you do with that? Okay, so therefore, let's follow their clue. Let's differentiate log x over x. Okay, so quotient rule. Yes. So what am I going to do? V u dash to start with. So that's going to be x. That's v, and u dash is 1 over x, right? Okay, v u dash minus u v dash. So u's just the numerator, right? And v dash will just be 1. So log x, I'll just chuck the 1 in there for completeness. Okay, all over v squared. Okay, now the denominator is looking good because that's sort of what we're going to be expecting. The numerator, not so much, right? Because what you've got over here is x times 1 over x is 1 minus log x. 1 over x squared. Okay, so now, what am I going to do here? It's not quite as obvious as before, where I had two things and like, oh, here's the one I want, so I'll just integrate it. So what I am going to have to do is break it up, right? I've got the log x over x squared, that's the part I want, and then I'm going to have 1 over x squared here, okay? So let's give this a go. 1 over x squared minus log x squared. Is that okay? Still got this here. And this is what I want to integrate. So I'm gonna move it over. I'm actually gonna swap these two around, okay? Because I want it to be positive. Yes. So I'll put the log x on x squared over here, and I'll move this derivative over. Okay. So now I can integrate everything with respect to x. So this will become what I'm after. There's the subject already. Now, when you integrate 1 over x squared, that's x to the minus 2, right? So reverse chain rule, usually when we differentiate, the power goes down. So this time, since we're integrating, the power goes up. So x to the minus 2 turns into x to the minus 1, okay? And then, you can't just leave it like that. There's something else we have to do. When you differentiate, you multiply by the power, right? So this time we should divide by the power, which in this case turns out to be the same thing. Okay, so dividing by minus 1 gives me a negative out the front. Okay. When you integrate this guy, you just get log x on x. Okay, plus my constant. Don't forget here. All right. So I'm almost done. Now I just need to tidy up. That's minus 1 over x. They have the same denominator already, actually. So minus 1 minus log x all over x. Ta-da. Okay. So it didn't end up being that much worse. The trick was, though, that what you get isn't straight away what you're after. Okay, so you've got to do a little bit of manipulation.